questions from the review worksheet, so.
All right. Oh, nice. Good. Yeah, that's helpful for me because I don't really I don't have most of these memorized anymore.
Gotcha.
I know how to use them, but I don't necessarily remember them off the top of my head. All right, so fine. Oh, I don't like how this is looking though, this background. Let me try opening that up again. Sometimes that happens. There we go. I'm like, you didn't put that fancy background in there, did you?
No. And also on the last page, I did post the answers.
Oh,
Answer
okay.
key.
Awesome. Find the first derivative and simplify. Box your final answer. All right, so the first derivative.
I believe this is chain rule, right?
Yeah, this is chain rule. So this is my u, right?
Yeah.
This is my u, and so it's kind of like saying 2u to the -3. So first I take the derivative of that, which would be -6u to the -4, right? And then I multiply it by the derivative of u, which is 4x cubed plus 12x squared, right? And then I can plug in that u back in there. Remember, that's your u. Does that make sense how I wrote it there?
Yeah.
So x to the 4th plus 4x cubed to the -4 times 4x cubed plus 12x squared. Now we should simplify this a little bit. So this is going to go to the bottom, right? Because it's a negative power. So the -6 stays on the top, and I can actually factor out a 4x squared. So let's change that. If I factor out a 4x squared, that's going to be -24x squared. And then you're going to have an x plus 3. Got it?
Yeah.
All over. Now let's factor out an x squared or x cubed from here. And you're going to have an x plus 4. So then I can cancel out 2 of those x squareds. So it's -24x plus 3 all over x plus 4. Whoops, times x.
Okay.
That makes sense how we did that?
Yeah.
So let's just make sure that that's right. You said it's on the last page?
Yeah.
Which number was it?
1.
So they actually didn't simplify it, which kind of surprises me. You would think that they would have simplified that. They just left it. Oh shoot. No, I made a mistake. I forgot to put the 4. I forgot to put the 4 down here when I brought that down. I forgot to make it 4. So you actually can't cancel those x's out. See how that 4, I forgot to write the 4 there. So those x squared still will actually, technically you could still take it out, but you're going to have to take out an x cubed, and then that will be to the 4th power. So
okay.
Probably and so you can still cancel some stuff out. So it's -24x squared times x plus 3, and then it's x cubed to the 4th, which is x to the 12th. You follow?
Yeah.
And then x plus 4. So really your answer, the simplified answer, is going to be this over x to the 10th times x plus 4. That's probably the best way to write the answer. They probably just don't need you to do that, is all, which is fun. But ultimately you're going to want, because remember what we're doing when we're finding the derivatives. What do we usually do once we find the derivative? What do we try to do with that?
We try to get it to the simplest form.
Simplest form so that we can solve, right? Set it equal to 0.
Yeah.
That'll give us the max and min points and special points like that. All right, so number 2. So we have a product rule and a chain rule going on here, right? So the derivative is going to be the first times the derivative of the second. I'm going to put a big box around it. So that's going to be 5 to the 4th times the derivative of what's inside. So I leave the inside for that part. And then I take the derivative of the inside, 3x squared minus 4. Make sense?
Yeah. Okay.
Plus, now take the second function unchanged, or the second function, and multiply it by the derivative of the first, which will put the 4 with that. It doesn't really matter where we put it as long as we
So
keep
it's
it
just,
there.
8x.
So 8x. And then, so the simplified form of this would be 20x squared, 3x squared minus 4, x cubed minus 4x to the 4th, plus 8x, x cubed minus 4x to the 5th. And you don't really want to multiply that stuff together because it'll just be too ugly. It doesn't really benefit you so much. I mean, it kind of does a little bit to factor some stuff out. You see how you can factor out these both have a 2 and an x, and then they have 4 of those in common. So if you wanted to factor that out, it would be, this isn't what the answer is going to say probably, but it would be 2 times x cubed minus 4x to the 4th. And then if you took that all out, what would be left behind would be 10x times 3x squared minus 4, right? And then over here, whoops, shouldn't have put that parentheses there, plus, actually I could have taken a 4 out, not just a 2. I bet. Let's do that. This one I could have taken a 4, not just a 2, right?
Yeah.
So the 4 out of there, then left here would be a 5, and left here would be a 2 and x, and then one of these, x cubed minus 4x. And I know that might not look as simple, but actually now you can actually simplify this, and it'll be in actually a better form. Because now if I multiply these things together here, I get 15x cubed minus 20x. And if I multiply these things here, I get plus 2x to the 4th minus 8x. So you can add those like terms together, and that's going to be 2x to the 4th plus 15x cubed minus 28x. And then this first thing here is going to be to the 4th. And then you have a 4x in front. So this is the simplest form for it. And actually now you can take another x out. See, I can take another x out of here and put it up into the front there. So this would actually even simpler. See if I can take anything else out. Now, I'm not going to take these x's out. Again, I guess I technically could. I could rewrite this. I'm getting a little bit too far ahead of I think where you're at right now, but
yeah, I think so.
I could do this and raise that whole thing to the 4th power. So that would mean this would be the 4th and that would be the 4th. So that means I can take 4 of those out. So it would be x to the 5th power. And actually then it'd be x to the 6th power because I'm going to take one of them out here as well. So x to the 6th times x squared minus 4 to the 4th times 2x to the 3rd plus 15x squared minus 28. And this is a much more useful form of that equation. Can you see why? Compared to this one up here?
Yeah, it's a lot shorter and more concise.
Well, and it's factored, right? Do you see how I can see how there's this factor, this factor, this factor?
Yeah.
Right? So this is a better form because if you're trying to set this equal to 0 or something, then you'd be able to do that relatively easily. And you can even, not that I'm going to, but you can even factor this even more if you really wanted to, because that's a difference with perfect squares. Anyway.
Gotcha.
All right. enough with the algebra showing off. I'll stop doing that now. I'll just do what probably they want it to be, because you're in basic calculus and that's probably all they want.
Yeah.
So this again should be this should be
Yeah, to the
right.
1/2. Yeah.
in the product rule, right? So
Yes.
the first function times the derivative of the second, which is going to be 1/2 x squared minus 2 to the negative 1/2. So that's the outer thing I took the derivative of, times the derivative of the inner thing, which is what?
That would just be 2x. Yeah, just 2x.
Just 2x, good. Plus, now take this thing and multiply it by the derivative of the first one,
That's
which is
just
what?
3.
Good. All right, now that we've done that, we can simplify this a little bit. So these 2's are going to cancel right here.
Wait, why
So,
did the bottom of the 1/2 cancel?
because this 2 is on the top and this 2 is on the bottom. And see how they're all,
okay.
yeah, they're all kind of being multiplied together. You could think of it as they're all being multiplied together.
Gotcha.
So this is the top, that's in the bottom. So I'm gonna move this. I'm gonna leave the 3x and then this x, so 3x squared on the top, right? And then this
Yeah.
thing is moved to the bottom as a square root of x squared minus 2, right?
Yes.
Plus 3 square root of x squared minus 2. Now, this is where I would actually be interested to see what the answer key is, because this does simplify more. And that's also why I was doing this kind of stuff, because you never really know how much they want you to simplify it. So I always just try to simplify it as much as I can. And to me, that's the simplest form. For this one, they probably want you to simplify it more, because watch what I can do here. I can multiply this on the top and bottom by the square root of x squared minus 2.
Yeah, I know we got to do that if I'm correct.
And that would square that, right? That would just square that, so we'll get rid of it. So this would equal 3x squared plus 3 times x squared minus 2 all over square root of x squared minus 2. You follow?
Yeah.
Which equals, what does that equal then?
6. Wait, no. Yeah, no,
Yep.
6x squared. Minus 6. So just
Good. That's it. Okay. So that's an example of why you always want to try to simplify, because sometimes when you do it, it really makes it look much neater, much cleaner, like in that case. Which,
yeah,
I would even factor it more. I would factor the 6 out, and that would give me x squared minus 1. And what is x squared minus 1?
x squared. Oh, just cancel.
It factors into that.
Oh.
And so your answer probably isn't going to be that, but I would write it like that, because that's much more valuable of a way to write it, because now I can see what the zeros are of this function and what the domain is, because that tells me the domain and this tells me the zeros.
Gotcha.
When you're dealing with rational functions. Okay.
All right.
Good with that?
Yeah.
Number 4, we're taking the derivative. This is the quotient rule, right? So it's the derivative is
Low D high minus high D low over low squared, right?
Perfect. Good job. Making sure I put the little derivative sign there, the little
Gotcha.
quotation mark, whatever we call it, prime. All right, so it's low D high.
So just 2
minus high.
So 2x, and then D low, is that just 2x?
4 minus x squared. Nope, it's 4 minus x squared. It's 1/2 of 4 minus x squared to the negative 1/2, right? It's the chain rule times negative 2x. So again, I can cancel this 2 out with that 2 like I did before.
Yeah.
Okay, and then over low squared, which is just going to be 4 minus x squared. So this equals 2 root 4 minus x squared minus, let's be careful with this now. We're going to have it's actually going to be a plus because there's two negatives that are getting multiplied. See that and that?
Oh yeah, minus and negative, so plus,
So
yeah.
that becomes a plus, that turns into a plus, and then it's 2, we still have a 2, and we still have an x squared on the top,
Yeah,
but then we have a square root of 4 minus x squared on the bottom of that part of that fraction, all over 4 minus x squared. So I have a compound fraction. And so if you remember me teaching you this before, I'm pretty sure I've taught this to you. Whenever you have something like this, multiply by the least common denominator. So I want to get rid of this.
yeah.
So I'm going to multiply everything on the top and bottom by this. So this is going to get multiplied in here and here. And it's also going to get multiplied here.
Why is he getting multiplied on the very bottom?
Well, because I can't multiply just on the top, right? What's anything over itself?
Oh,
It's 1,
gotcha.
right? If I had 3/5, can't I just multiply that by 7 over 7 and make it 21/35? Isn't that the same thing?
Yes, it is.
Why can I? Because this is just what?
That's just one.
And so I can't just multiply just the top. I have to multiply the top and the bottom, or I have to multiply the top and the bottom of this. That's the other way you could do it. That's the way that sometimes you'll see people do it. Get a common denominator, deal with just that first, and then deal with the bottom. I don't prefer to do that, and you'll see why. This makes it really easy, and it cleans it up really nicely. So multiplying that here does what to the square root?
It cancels it out.
So I just get 2 times 4 minus x squared. And multiplying this here does what to the denominator?
It cancels the denominator out.
It cancels the whole denominator. So see how nice and clean that numerator became?
Yeah.
And then the denominator is just 4 minus x squared to the 3/2. Because this is like the first power and this is like the 1/2 power. So you just add powers together. And that just equals, this becomes 8 minus 2x squared. So the 2x squareds cancel out. That just becomes 8 over 4 minus x cubed to the 3/2.
Gotcha. Yeah, and they want us to actually keep though in the denominator the square root and then the parenthesis part. They want us to keep those broken up.
Okay, so that in that case you would say,
it's 8 over 4 minus x squared and then the square root of 4 minus x squared.
Okay. I see what you're saying. Yeah, that's fine. You can do it like that. But honestly, this again,
the way that you showed makes it more simpler.
Yeah, that's the cleaner way and probably the more appropriate way to write it, just FYI. All right, next. What are we gonna do for this?
These are, gosh, this is when we start getting into the rules.
Yeah,
actually put those on the first page.
Yeah, that's all right. But I remember number 5. You know what we can do? We can drag this. We can just drag it over to like in front of it. That's a good way to do it. So now it's between 3 and 5. So we'll just go to the right to look at it. So the derivative of sine. So this is a quotient rule, right?
Yes, I believe so.
Low, d high,
which is 1 minus cosine. Isn't that sine? So it's just cosine.
No, we were thinking of 1 minus cosine squared.
Oh, okay. So it's just gonna be 1 minus sine u.
Well, what's the Just take the derivative. What's the derivative of 1?
Oh, nothing. So it's just
0. And
cosine, which is
carefully,
sine.
it's a negative sign,
Oh,
but it's a
sine.
negative sign, right? Which becomes sine. Follow that?
Why is it a negative? Because, oh, wait, because positive cosine goes to negative sine. Okay, I
That's right.
see. So,
Okay.
so it's just sine. Okay.
Minus, so low D high minus
High
high
D low.
D low. And what's the D of the low?
Just cosine of
Good.
X.
All over low squared. So let's clean this up. This is sine squared X minus
1 minus cosine.
minus cosine squared X. So let's clean that up. All over sine squared X. So that's distributing this thing in here. That becomes a negative and a positive. So I'm going to move it around. What's sine squared X plus cosine squared X equal to?
Is that, oh gosh, is that tangent squared X? No.
No, you said it before, I think. What's sine squared plus cosine squared?
Oh, just 1.
It's 1. So this just equals 1 minus cosine X all
Over
over.
sine squared X.
But now what's sine squared X? Isn't it 1 minus cosine
Yes.
squared X?
Yeah.
And can't I then factor this into
Oh, so it's 1 over 1 minus cosine
1
X.
minus cosine X, 1 plus cosine X? So what happens? Gone, gone. And you just get 1 over 1 plus cosine X. Now, that's crazy. What I just showed you is a lot of simplifying. But do you remember when you did trig identities last year?
Yeah.
That's why you do trig identities, so you can simplify when you're doing this kind of stuff in
Gotcha.
calculus. So let's
Yeah,
find out. That's how they wrote the answer.
Yeah, they actually wrote it. They just want us to keep the denominator the same out for this one. I don't know why they
Okay.
do that, but I guess it is kind of simplifying it. Well, making it simpler to do, but it's not the simplest form.
Yeah, I would maybe even ask your teacher, like, do you not want us to simplify it more? Because this is, like I said, that's the whole reason that you did what you did in pre-calc with trig identities. But anyway, that's fine. Either one is fine. I guess they're happy with either one. So it's either 1 minus cosine over sine squared.
Yeah.
So that's what they did. They did 1 minus cosine X over sine squared, and that's where they left it. But I'm telling you that this is a simpler way. This is a simpler one. They just probably don't expect you to do that yet.
Yeah.
At this point in calc, which is totally fine. Totally fine. All right.
That'll probably be
Now,
right when we get back from break when we simplify that part.
maybe. Now I need to look at the cheat sheet because I don't remember. Cosine inverse, the derivative of cosine inverse. Where's that at? Right here. Negative 1 over the square root of 1 minus u squared times du. So what's your u?
Your U is that that part that you just circled.
Yeah.
2
good.
square root X.
So the derivative is, again, I got to look at it carefully. Negative 1 over square root of 1 minus u squared. Negative 1 over the square root of 1 minus u squared is just going to be 4x.
Yeah.
Right? And then times
Yeah.
the derivative of u, which is going to be 1/2 times 2, so that's just 1, times x to the negative 1/2. Got it?
Yeah.
So this simplifies to negative 1 over the square root of x times the square root of 1 minus 4x. But then when you do this kind of thing, you can just multiply them. Since they both are square roots, you can multiply them together. So the simplest way to write this, the best way to write this is square root of x minus 4x squared. Let's see if that's how they wanted you to write it.
It's first.
Of 1 minus 4x. Yeah, pretty much they just didn't multiply the x in there. Did I keep the negative in there?
Gotcha.
Yeah,
So you're just going one step further then.
It's fine if you don't multiply it in, but yeah. In fact, probably in this case, it's better to not multiply it in because it's in more of a factored form. Right?
Yeah.
So that's fine. Okay, good.
All right. Off page
Page
5.
All right. We did these the other day. You want to try this one?
Oh gosh.
Tell me what to write.
Here, let me pull up the cheat sheet.
Yeah,
So
look at
yeah, I got it on my second screen. So this one is
one of the ones on the bottom.
oh yeah, it is the ones on the bottom.
A, B, C, or D on the bottom.
I believe it's B for this one because it's A, so it's just the number.
Mm-hmm.
All right.
So what do we do?
Here we go. Go to page 5. All right, so you're gonna do y equals, and then it's gonna be AU. So it's 2 and then 3x minus 1 is the exponent.
Mm-hmm.
Inverse 2.
You mean natural log of 2?
I mean natural log of 2.
I know you.
It's probably gonna be years from now. I'm still gonna be calling it inverse. I don't know why I got that in my head originally.
Yeah.
And then since it's 3x minus 1, that's just gonna be 3.
Perfect. There it is. So again, there's a couple different ways to write this, but
Yeah. Then that's it, I believe.
Yeah, that's probably the way they want you to write it is like 3 ln 2 times 2 to the 3x minus 1. That's probably what they want you to do. Again, let's
see.
What form they write it in. All right, they just kept it like that.
Okay. Either way, it's fine. It's just two different ways of writing it.
Yeah. It's really a coefficient, so a lot of times you put the coefficient in the front, right? This is like the coefficient now. It's the number part of it. That's why I like to put that in the front. All right, how about for this next one? What do I do?
So if it's log, this is gonna be, this is the same one, so that's gonna be C.
Mm-hmm. So 1 over ln of A, or 1 over u ln of A.
Yeah. So it's gonna be 1 over u, which is 4x plus 1. Natural log of 2. And then times du dx, so it's just 4. And then that just simplifies to 4 over 4x plus 1, and then and natural log 2.
Mm-hmm. Perfect. And these cannot cancel out because this is inside the function, the log, natural log function, right?
Yeah. All right. Numeral 6, that is the natural log. Here, actually, I'm gonna do something quickly. This is gonna make it our lives so much easier. Here. All right. That's gonna make our lives easier. I'm just gonna
Smart.
All right. So for this one, it is natural log, so it's gonna be D.
Mm-hmm.
So it's 1 over u. Oh wait, we still gotta do one more thing with the tangent, right? First.
No, you're right. 1 over u.
Oh, okay.
So u is that whole thing, right?
Yeah, 2x minus tan x.
Mm-hmm.
And then du dx. So is that one we have to do something with tangent, right?
Yeah, what's the tan? Yep. So what's the derivative of 2x?
Just 2,
Mm-hmm.
and the tangent will be secant squared.
Is that what it is? I don't remember. Is it negative secant squared or positive secant squared?
Just positive secant squared.
And okay, perfect.
And that will go on the top, so it'll be 2 negative secant squared x over 2x minus tangent x.
Good.
And this is xe, so it's going to be the first one. So it's going to be,
So what do I do first?
um,
How do I deal with that 4x in front of it?
don't you have to do chain rule on that? Well, oh gosh, is it
Chain,
first
just
derivative, second
see how it's a
derivative first? No,
see how
first
it's a
derivative, second. Yeah,
it's
no, I said it right.
product rule.
Yeah.
So first, it doesn't matter which one you do first, but so I 4x times the derivative of e to the 2x, which is 2e to the 2x.
Yeah.
Got it? Plus
And then it's
4
going to be,
e to the 2x
yeah.
is the derivative. Yeah. So then you can simplify that a little bit. You can take it, make it 8. You can actually factor out a 4e to the 2x. In my opinion, this would be the better way to do it. And you'd be left with a 2x plus 1. And to me, that's a much better looking way to write it than any other way. But that's probably not going to be the answer, but this is the way you'd want to write it because that's the factored form. But again, like I said, they probably don't care. He probably doesn't care right now if you're writing it that way or not. So that's why they'll do. All right, how about this one?
Ooh, sine then cosine then x squared. So yeah, it's gonna be, so sine is, so it's gonna be cosine sine x squared.
Cosine of cosine x squared, because the chain rule is you take the outer function and leaving the inner function unchanged. They're, by the way, they're missing a parentheses here. Got it? And then I multiply that by the derivative of the inner function, which is the cosine of x squared. But how do I take the derivative of the cosine of x squared? I do the chain. I do the chain rule again. Do you see that?
So yeah, so it's going to be negative sine.
Leave that unchanged. And then finally, multiply it by the derivative of the innermost function, which is 2x.
Okay. I think, are we done there?
Not quite.
Oh, we got to multiply the cosines together, right? Simplify it a bit.
No, you can't really multiply them together. But you can clean it up a little bit. I'm going to put the negative 2x out front, and then the sine x squared, and then the cosine of cosine x squared. That's how you should write it, I think. Check the answer on that.
Right now. Yeah, it looks good. Yeah, it's cosine x squared. Yep. They're written the same way.
And how about this next one?
Numeral 12. That's gonna be cosine, so it's gonna be sine, and then
what do I write?
2x over x plus 1. I mean x minus 1.
Good.
And then you're gonna have to factor that, I believe, right?
Not factor it.
Oh, low d high minus high d low over low squared. Right, you gotta do that.
Yep, low d high minus high D low,
D
which is
low, which is just at 1. So it doesn't matter. And then over the low squared.
so let's simplify that in red up here. So this is going to be 2x minus 2 minus 2x. So those cancel out. It's just -2. So this is -2 over x minus 1 squared times the sine of 2x over x minus 1.
Yes. All right, then I'm gonna believe that's it, right? Well,
That was that.
they have 2 sine. Yeah, and then 2x and then x minus 1 over x minus 1 squared.
The same thing? Or do you need me to check it?
Wait, looks slightly different.
Tell me what they have.
2 sine and then 2x over x minus 1 in parentheses, and then that's all over x minus 1 squared.
So they don't have the negative?
No, they don't.
I think they should.
It could be a typo also.
Let's see if that negative is supposed to be there. I believe it is, because look up here. It's low times the derivative of the high, which is just +2.
Yeah.
So that was a x minus 1. So when I multiply it by the 2, it's going to be a -2.
Yeah, it is gonna be a -2.
So I'm pretty sure that we have it right.
I'm pretty sure, yeah, it's just a typo.
I'm
Yeah,
looking
it
to see
might
if
just be one.
yeah, I'm pretty sure we're right.
Okay.
Talk to your teacher about that, get some bonus points.
Yeah.
All right, write the equation of the tangent.
So we were working on this
Line.
one the other day also.
This one, was it the same one or similar to it?
I believe so. Here, let me check. Right, the equations of the tangent line and the normal line.
So the tangent line, it's going to be the derivative, or the slope of that is going to be the derivative of that function at the point 2.
Yeah.
Right? So we're going to have to find the derivative of this, which is just going to be 2 plus, what is it, 1 over 1 over x, just 1 over x.
Yes, I believe so.
The natural log, it's 1 over u times the derivative of u. So 1 over
Right, it's
3
this one.
times the derivative, which is 3. So it's just 1 over x.
Yeah.
So it's just 2 times 1 over x, or 2 plus 1 over x. And if we want that at 2, then at 2, that's going to be 2.5. Right?
Yeah.
2 or 5 halves. So that's my slope. And my point, if I plug in 2 to the original function, I get 2 times 2 plus the natural log of 6. So I just get 4 plus the natural log of 6. So that's my point. 2 comma 4 plus the natural log of 6 is my point.
Yeah.
So the equation of the tangent line is just going to be y minus y1.
Yes.
Put that in parentheses to be safe, equals the slope times x minus x1.
Yeah.
And you can simplify that a little bit if you want, but I don't know that they really care for that. And then the equation of the normal line, you just take the negative reciprocal. That point is still the same, right? Because that's on the normal line and on the tangent line. But this just becomes the negative reciprocal.
Oh, yeah. Yeah.
Okay.
And that's
So
it.
those are your two answers. Is that the right answer?
I believe so.
Yeah.
This is
No, they just distributed that negative
12.
in there.
No,
That's all.
yeah. Okay.
But you really don't even have to do that. That's not a big deal. Okay.
All right,
Good.
and then this one we actually worked on in class today. Yeah, this is what we did in class today, and then the 10th page 10 is, which is question 15, we have not done yet, actually.
So do you want to do this one or no?
I'm not quite familiar with this, so here, let me actually grab
Yeah,
my
I can.
notes for
No,
this.
I can.
Oh,
I
okay.
can. I'm
Yeah,
just wondering.
it's like,
I'm asking you if you want me to do it or not.
yeah, if you can do that, because yeah, this is like one of those things. Like I know how to do some of them, but not all of them yet.
Okay. So it says suppose f and g and their first derivatives have the following values at 2 and 3. So that's that table. Evaluate each derivative with respect to x of the following functions and the given values. All right. So at 2, if I want to find the derivative, I'm going to have to use the
Table.
product rule, right? So it's the
Yeah.
first times the derivative of the second plus the
Oh, and
second
then
times the derivative of the first.
yes.
So when I plug in 2,
So it's gonna be F and then in parentheses 4, right?
no, f of 2. No. So this is f of 2 g
Yeah,
prime
which is 4.
plus g of 2 f prime of 2. That's what we're doing for all these things. So this
Oh,
is
right, and then we're sorry, yeah. So it's
yeah,
gonna
that
be 4 times G prime, which is 1,
mhm.
and then plus G, which is 3, and then F prime, which is -5, so it's -15. So it's gonna be 4 minus 15, which is -11.
Good. And for this other one, now we're using the chain rule, right? So the derivative of this is the derivative of the outer function with the inner function unchanged. And I'm going to go ahead and plug the 3 in there. Times the derivative of the inner function. Does that make sense?
Yeah.
So now just plug them in. So what is f of or what's g of 3?
G of 3 is, oh wait, G of 3 does 2.
Good. And it's a good thing it's 2, because if it wasn't, we wouldn't be able to find this. We wouldn't have to find the value because it'd have to be 2 or 3. And what's g prime of 3?
G prime of 3 is going to be -2.
Good. And what's f prime of 2 now?
F prime of 2, -5. So it's going to be -10 times -2, which is +10.
Yeah. You didn't quite say that right, but you did it right. Good.
Well,
Nice. Got it?
all right.
Makes sense?
Yeah. All right.
All right.
This is new to me.
Okay.
So yeah.
This is just one of the applications of derivatives.
Yes.
Okay. So if you're working in a manufacturing plant, you have these formulas that you get based upon your production, and you use these formulas and you use them to maximize the profit or minimize the cost or whatever that might be. Maybe.
Is this actually like a real world application to it?
Mhm.
Like you could
Yeah.
theoretically have to do this?
Yeah, exactly. So the total cost C in dollars of manufacturing X units of a certain product is this. So at some company, they determined by using, extrapolation or modeling, they determined that this is the formula that represents the cost for X units. To make X units of a certain product, you plug in X and that will give you the cost. And see how it's a cubic? It's a cubic function. So that means it's something like this. It's a positive leading coefficient. So it's something like this.
Okay.
And they're saying find out what the rate of change of the cost is. That's the derivative, right? With respect to the number of units. Well, that's easy. Just take the derivative, right?
Oh, so it's going to
So
be 6x squared minus 6. That's it.
That's it. And that is the rate of change of the cost. So if your function, let's go ahead and even just look at the actual function itself. Okay. The function is going to look like this. It's going to be 2x cubed minus 6x plus 175. So if I look at the graph, you can see what that graph looks like. And now,
Oh, yeah, it's a cubic.
does it make sense that would it make sense that the graph would be would you have to worry about anything left of 0?
No, you wouldn't. Well,
would not.
actually, no.
No, you would not. That's right. You wouldn't have to worry about anything. Save to photos. Let's see if this is going to work. So I'm going to go ahead and pull that. Whoops. I'm going to pull that graph into our picture here.
That's cool how on the iPads you can do that.
So there's my function, right?
Yeah.
So what really matters is probably this right here starting here. That's really all that matters. Like, I don't care about this over here. That doesn't matter. That's not part of my domain, right? But
Yeah.
can you see what happens at the start? It dips down. You see how the cost dips down right here?
Yeah.
Then it goes up. And if you're looking at the derivative of this tells you the rate of change of the cost. And what might I want to know? I might want to know when the rate of change bottoms out. Right?
Gotcha. Yeah.
That would be a valuable thing to know, because if I get past this point, what's happening to the cost?
It's going up.
It's starting to skyrocket. So what point would I really want to use? I'd want to use that minimum point.
Yeah.
And how do I find that minimum point?
Plug it in.
I set the derivative equal to
0.
And that's how I find this minimum point, because that's what the derivative tells you, the slope of the tangent line at that point. So where is the slope? 0? The slope is 0 at that bottom point right there.
Gotcha.
That makes sense. So that
Yeah.
value right there is going to be, and we can find it by solving this equation. 0 equals 6x squared minus 1. Oh, sorry, minus 6. So let's factor a 6 out. X squared minus 1. So it's x plus 1, x minus 1. Where are the 2 zeros at? Where are the two?
Positive 1, negative 1.
At positive 1 and at negative 1. Guess what the positive 1 was? It was this one right here.
Gotcha. And then the negative 1 was somewhere.
And this is this is the one where it was, I'm sorry, positive 1 was here, my bad. And negative 1 was here.
Oh, okay.
So
yeah, because it's telling you on the x-axis.
Yeah. Does that make sense?
Yeah.
So it says find the rate of change of the cost of producing 180 units.
Did you just plug 180 in for x?
Find the rate of change of the cost of producing 180 units. So, yeah, you plug in. Actually, I'm gonna have to read what this says. Was this in hundreds? In dollars? That was in dollars. Let's see, hold on. Find
dollars in dollars.
Okay, the rate of change of cost C with respect to the number of units manufactured. The total cost C in dollars at X units.
15B.
So I'm trying to think of what this actually is kind of.
I think we're gonna have to plug that in. So I think this is a calculator problem.
We are gonna have to plug it in, but find the rate of change of the cost of producing 180 units. That seems a little big. You're gonna plug in 180 into X. That's gonna be an extremely high rate of change.
I'm hoping that you'll let us use a calc.
Yeah, it is. Look at how.
That's a big number.
Yeah, that's a huge cost.
Okay, so she better let us use a calculator for this part.
So you're gonna plug in 180 squared. And then multiply that by 6 and then
Let's
subtract.
subtract 6. Yep,
One.
194394, and
Four,
her answer
three,
is
four.
194394. Yep. And then you
That's-
do have to do this in a complete sentence,
Yeah,
I believe,
that's a
but
really
that's
big
fine.
rate of change.
It is.
It's a really big rate of change. How did I put that here?
Yeah, I think you did do it on the axis.
It was on the axis, but I'm having a hard time. Oh, okay, there it
There
was.
we go.
I have to zoom it the right amount. There we go. Okay, makes sense. We good?
Yeah.
That's kind of a weird question. I don't know, that the formula doesn't seem to be exactly right, because the cost, like the optimum cost is when you just produce one. The minimum cost is when you produce one. And then as soon as you produce two, the cost of production just skyrockets. So when you produce, the more you produce, the more expensive it is, and the more you have to charge to recoup your cost. That's not
weird.
That's not typical of these
No,
kind
it
of
isn't.
problems. It's kind of a weird problem, at least in my from the way I'm thinking about it. It seems
I don't
like,
know what they're producing. It must be the rarest thing in the world.
well, maybe it's Bitcoin.
Maybe.
No, I don't know. I'm just kidding. Bitcoin is one of those things that's confusing and doesn't make sense all the time. Anyway,
Yeah.
sound good? Do you have any other questions, or is that it?
That's actually it.
All right. Well, hey, I'll see you coming Saturday, right?
Not this Saturday.
Oh, it's not. Okay.
Yeah, that's Saturday the 10th, and then